Hello and welcome back to another video. In this problem, we're told to let f of x equal 1 over x and g of x equal 1 over x squared. And we're asked to find the composition f of g of x. So f of g of x, this is equal to f taking on the value of g of x. So this is equal to f of, what is g of x? 1 over x squared. And so f of x is equal to 1 over x. F of g of x is going to be equal to 1 over g of x, right? So wherever you see an x, you're plugging in g of x. So this is 1 over x squared. So if this is 1 divided by 1 over x squared, right, which is another way to write this fraction, we can say that this is equal to 1 times x squared over 1. If you flip the operation, you flip the fraction. 1 times x squared over 1 is x squared. Therefore, f of g of x is equal to x squared. And we're asked, is this function continuous everywhere? And so we know from Theorem 9 that if the function g is continuous at a, right? Any given point a, and f is continuous at g of a, then f of g of x is continuous at f of g of a. And the extrapolation from this is saying if g is continuous everywhere and f is continuous at all values of g, then f of g of x is continuous everywhere. And we can see that f of x is not continuous everywhere, right? Or g of x is not continuous everywhere, because if you plug in a 0, then you're going to get 1 divided by 0. You can't divide by 0. There is no output of the function. However, what this function is not saying is if g is not continuous at a, f of g is not continuous, right? The opposite is not necessarily true. So since we're just looking at f of g of x is equal to x squared, this is a polynomial. Polynomials are continuous everywhere. Therefore, this function is continuous everywhere. We can say yes, f of g is continuous everywhere.